Hello and welcome to Apache TinkerPop's home here on Twitch. Today we have another TinkerPop Wide stream where we explore the wider TinkerPop community, look at tools, libraries, or graph systems built on the TinkerPop framework, or even sometimes applications built on those foundations. And today I'm here with Daniel Weber to talk about Gremlinq, type-safe object graph mapper for .NET. He and I actually recently authored a blog post together about how to effectively use Gremlinq with Amazon Neptune. And this stream today is a bit of a companion piece to that article. And, Daniel, happy to have you here today to help talk more about Gremlinq.
Thank you. Thank you for having me. It's an honor and a pleasure.
Well, before we kind of get into things, I would share this link to the blog post that we kind of developed over the course of a few months. It kind of took a little bit, but it finally made it through. It's one of the longer posts that I think I've been a part of writing. So there's a ton of great examples in there, courtesy of Daniel. So yeah, please check that out. If you ever have any feedback, please let us know. So with that though, Daniel, let's maybe kind of jump into your side of things. Like what's Gremlinq and what's happening with it these days?
Gremlinq is what I call an object graph mapper. So if you, from the traditional relational world, think Hibernate in Java and Hibernate in .NET. So these tools allow you to reason about your domain objects in your native language instead of reasoning about them in any other graph query language, be it SQL or in our matters, Gremlin. So I'm not sure if that term object graph mapper was around before. I have seen it pop up, so I think it was around before. But that's what I called it.
Yeah, so there were definitely a few that existed. I mean, none in .NET that I know of. I mean, I think yours was the first that I can recall that landed for .NET. But Python, I think, was maybe one of the first ones to have one. In fact, multiple ones were built. I think that maybe the earliest one was called what? Oh my gosh, James Thornton wrote it. Oh my goodness, can't remember. That's a pity. I was just looking at it the other day. But okay, in any event, lots of a number of them, but definitely I think Gremlinq was the first one to really show up in .NET for sure.
Yeah, I should have said that. It's in .NET object graph mapper. So the language in which it enables you to write your queries in would be C#. And what is it up to about these days? I'm close to releasing version 14, a rather minor bump, a major bump, but minor changes. Some housekeeping. We're obsoleting some things because over the course of, let's say, version 12, 13, Gremlinq has become really mature. So the public API, the API surface doesn't really change that much, other from additions to the API. So yeah, it's good, going good. I don't have too much feedback these days about people using it, developers using it, but that doesn't. I know for a fact that it's being used in some projects, in some commercial projects.
But, yeah, I mean, feedback's always hard though, right? Particularly with like open source software. I mean, we only hear about TinkerPop when something's broken or something's awful. So it's every once in a while we do get somebody. I did get somebody who pats you on the back and says, "Hey, that we really enjoy using this, and it's a great thing." So I don't know, help your pat your favorite open source contributor on the back. Let them know when you find something good.
I know there's GitHub stars, but that's about that, right?
Yeah. Okay. Well, yeah, I mean, yeah, I know you have kind of a presentation to kind of go through here. Feel free to kind of drive right into that.
All right. So I thought about what the target audience about this of this talk should be, and of course I could do another introductory talk as a companion piece to, as you mentioned, to the blog post. But I feel it has been done at least once, and it's been a while. So I figured some of the feedback I get from developers, some of the feedback is while Gremlinq tries to lower the barrier of writing queries in a type-safe manner, and trying to lowering the entry barrier of getting into graph databases in the first place, developers often hit another barrier right away, which is how do you deal with types, the type system of Gremlinq. So it assumes a type system. It's got types all the way long, element types and the interface types, but it's not often that easy to know when to use what, or to make things work when they don't, or to make queries match when they don't agree on types and interfaces. So yeah, this is going to be a deep dive called Every Hop Strongly Typed, and the hop is a bit of a bit of a wordplay, because you hop in your graph, and the domain that we're going to look at is the arrows domain by Kelvin Lawrence. You could apply such a notion of a hop as well, right? So this hop is kind of carries a double meaning. And the deep dive I'm going to present, yeah, we're going to go into the Gremlinq type system. We're going to go into the element types that are carried around throughout any Gremlinq query. But first, this being a deep dive, I thought about, okay, I still want this talk to be somewhat self-contained. I can't really make it self-contained because it would take 3 hours, and I guess it's safe to assume that people watching already on the Twitch stream right now are somewhat familiar with graph databases in general and Gremlin per se. But I still want to enable our developers, whenever this goes up on YouTube, and I would link to it, I would still want to include developers that might not be familiar with either of these things, be it graph databases, .NET maybe, the query language. So what I'm going to do is present a very, very short introduction, a few slides, very short. It's the idea being that should you feel intrigued by any of this, pause the video, become an expert, so to say, and come back and continue dabbling with Gremlinq if you want to. So once I'm done with explaining the most basic things, and even Gremlinq, I will assume familiarity with these things. So I can then continue the deep dive. That's cool. If that's cool with you. Yep, so I would just start out with the usual opposites, not really, but the traditional way we had it for, like, I don't know, 50 years, because before even no SQL databases were around. And I think the usual other way to model a domain in a database would be the relational model. Of course, there's no SQL, there's key value stores and all that, and document databases and whatnot. But to describe what we're going to be talking about, relational databases would store your data in tables, and those tables would have links to other tables, foreign keys pointing into other tables. You could You could store your domain objects, your domain information in there, as well as relationships between those objects or between those records. And what a graph database does is making these objects or these concepts and the relationships between them explicit. So it's important to say that a graph data, it's a conceptual view on the data. It's got nothing to do with storage per se, because there's many means to store a graph database. There's lots of graph databases storing things in all kinds of ways. But the conceptual view on things in a graph database is that your domain is modeled as things and relationships between those things. And in our world, the TinkerPop world, I assume there's already also different ways of describing a graph or viewing a graph. But the TinkerPop way of dealing with graphs is we observe labeled property graphs. And what that means is you have nodes. Those nodes always have an ID. Those nodes always have a label. And they have properties. They might have no properties at all, but they might have lots of properties. And as with your regular SQL database, those properties can have a range of data types, right? Strings, integers, you name it. So this, in our case, this node here on the left would have the idea of one. Its label would be an airport. That's the domain we're dealing with. For the remainder of this, and the other node on the right has an ID of two. It's also an airport, but they differ in their properties. The left one being JFK Airport, and this one being LAX. And they are connected by another element. Those are all elements, nodes and relationships, vertices and edges, are both elements. This has an ID of 3, a label of route. So airports are connected by edges labeled route. And it's got a property, distance, or dist in this. And as every database, these databases come with a query language. In our case, the Apache TinkerPop case, it's Gremlin. So what Gremlin does is it's a procedural way of querying your data, in contrast to a more declarative way of querying data. So what you do in Gremlin is think of those tiny little gremlins. You put them on certain vertices to start with. Could be all of them. So that's what the uppercase V does. So you have a tiny little gremlin on all of the vertices. So now you go and filter those which have a label of airport. In our case, there's no filtering because they all have the label airport. And now you're going to filter on those that have a code equal to JFK. This one will just leave one gremlin left. So now you can walk the graph by out-E walking those edges labeled route. So that would put the, actually I forgot one. Think of a third gremlin on the left. This would put those gremlins, split up the one gremlin into two that are now standing on the routes to other airports. And now we could filter those edges, but just the ones who have a property value of distance greater than 1,000. That would, in our case, in our example, just leave that one. And envy means we go into the adjacent vertex. So we left a vertex, we stood on that edge, we go to the adjacent vertex, and here we are. And this would be our result set, right? So this is how the most basic query in Gremlin that I could come up with. So what ExRam.Gremlinq does, as I said in the introduction, is it's an object graph mapper. Yeah, think and hibernate. I already said that, and it's been around since 2017. And the query would looks somewhat like this. So you're now reasoning about classes in your language, C#, and for that matter. So you would have a POCO, we call it, a plain old C object, which is actually a class called airport. It would have all those properties that an airport would have, in this case, a code and the name. But we're type safe now, right? So we're, instead of going V and has label, we can say V and those angle brackets airports. So we already type safe. We already only assuming those airports, those nodes with a label of airport. And filtering goes as type safe. So we can reason about what we try to express on those airports by using properties in our code. So we would have this lambda, and we could say x goes to x dot code equals JFK, which is a perfectly valid type safe C# expression, right? And same for the route class. It's a class in your domain, in your set of classes, in your set of domain classes. And again, you can filter because the route class has a property called dist. And you can go the NV. Again, filtering on those nodes that are airports. This is we're gonna see later on. This is a necessity because there's no way to know that the adjacent vertex is actually labeled airport. So we go ahead and tell it to Gremlin, right? Go to the adjacent vertex that are labeled airport. And to array async, optionally taking a cancellation token, would asynchronously exit the queries and give you the results. So this is what Gremlinq does. So for the remainder, just it wasn't that brief. I apologize. We're going to do some code. So we're going to create a new project with one of the .NET new templates that are included in ExRam.Gremlinq. We're going to run quickly, very well. I have a reputation for telling I'm going to do it quickly and then don't. We're gonna
I like a good story. So yeah, if you have a good story, I'll listen.
Yeah, let's see how it goes. We're going to run through those queries, and then we're going to do the deep dive. So let's look at what we have. What does our API give us? What does it say? Where's the elements? What are the interfaces for that Gremlinq provides? So we have element types. That will be your domain types, your airport, your route. Of course, we have scalars, integers for counting things and other things. There's tuples. Whenever you do a projection, you can project to tuples. You can also project to C# dynamics. And there is your data transfer object, something that you would create on the fly, something that only your code knows about, something that is not a domain object, something that nobody else has to know about, but only your code. And you can reason and use those in Gremlinq as well. Then we going further, exploring Gremlinq's own type system. It's got a range of different interfaces, which allow you to only use those methods in any context that are valid at this point. So this is being done by, this fluent interface is being facilitated by a wide range of different interface types coming from Gremlinq. And then we got step labels as well. Step labels are those things in Gremlin where you put standing, again, imagine those tiny gremlins standing somewhere, putting a pebble, dropping a pebble, and later remembering where that pebble was and what it was. We're going to dive a little bit deeper, think about casting in Gremlinq. So what is a cast versus of type, for example. We're going to talk about lowering. When do you have to actually kind of bend your type system while writing queries, because they don't always have all the information, and you sometimes have to give it a bit of context and make it do the things you want to do it. And there's force methods that would allow you to force types, element types, interface types, all these things to make your Gremlinq query behave the way you want to. We're going to talk about domain-specific languages, because now you got types, and you're already thinking schema. And schema is not, correct me if I'm wrong, it's not a TinkerPop thing per se, but it might be some at some point. I think there's Janus graph around, which allows you to define some notion of a schema, but you could also define a notion of a schema in your code just by lifting your notion of domains, not only reasoning about airports and routes, but maybe reasoning about something you call neighbors and hiding this in a domain-specific language. So you could not even more reason about out edges and walking here and walking there, but only reason about your domain and your domain-specific language. This is a possibility that Gremlinq gives you through C# extension methods, which are quite suitable for these things. I'm gonna show you how we would do this.
Yeah, schema's been discussed pretty heavily the last few months, I'd say. So yeah, I think we could hoping to see something sometime this year in relation to schema. So we'll see how that goes.
Great. This would go into the 4.0 branch.
4, yeah, it would go to 4. Yes.
Great. So yeah, that's probably something to adapt for Gremlinq, right? Once you would probably have a schema language, and
yeah, I'd encourage you to go look at the if you haven't noticed those posts on the dev list. Cole Greer's been kind of at least sort of organizing the meetings and the discussion around that. There's been a lot of input from Peter from SQLG and from Josh Chenevere and some others. So a lot of people have kind of checked in on the schema talk. So yeah, if you had thoughts and ideas, it's probably something you can look into. But yeah, maybe ask Cole about what the latest is with that. But there's also some posts on the dev list too that you could probably look at.
I am on those lists. I wish I had the time to read all these things.
Just have your agent do it.
Yeah. Oh yeah. Right. Tell me the state of.
There's actually an MCP server. I think there's an MCP server for the Apache mailing lists. So like it has like all these features built in to search the list and pick it apart and all kind of stuff.
That's cool.
Yeah.
All right. If time permits, in the end, I would go ahead and shamelessly plug some of the extensions for Gremlinq. Gremlinq, it's open source, it's MIT licensed, but there's some things that I set out to be offered commercially. Some features developers requested throughout the years, and yeah, I would really like to do this to make Gremlinq development sustainable, as we all do in open source. It's always the next thought is, how do we make this sustainable, right? So the Gremlinq extensions is one way to kind of cater to some of the requests that have reached me over the years. Of course, there's always too less of everything, not enough time to do it all. There's lots of ideas. I'm open to ideas. If there's any, I'm open to any anything that you might need and that I could offer. But yeah, if time permits, I would just show you some of the already existing extensions. All right, that being said, I would go ahead with the template, right? And just create a very basic, not so basic, but create a new project from the .NET new Gremlinq template. So how this goes is the obvious way is to do .NET new. There's two templates, one for Gremlin console and one for Gremlin ASP.NET. So you would already have an ASP.NET tiny little server sitting there doing something in the backend with Gremlinq. But I'm opting for the console. I'm going to name it every hop strongly typed, just as this talk. We're going to use a Gremlin server and one that would run locally as a Docker container. There's a feature in Gremlinq only added recently that would add the feature of running throwaway Docker containers for every time you do something, you start your application or you start your tests. So there's a library called test containers, which does just that. Put up those throwaway containers every time you need them in the back and clean them up afterwards. So this is a very nice way to really get started. Beforehand, we would have those templates, and you would have to start your own Gremlin server and download it, or maybe even already started in Docker. But there was always this extra step being involved. Now we have used test containers, and I hope it does all the things we need. So let's go. I should have installed those templates to begin with. I'm sorry. So yeah. The way you install these is .NET new install ExRam.Gremlinq templates, the obvious usual way to install a template, just a regular NuGet package sitting there to be downloaded. And it's got all the templates. It's just gonna take a minute. Now we have them. So let's go from there. Let's dive right in, open it in Visual Studio. And Steven, I would like you to, whenever there's something that is not perfectly visible, just give me a hint.
Sure, absolutely.
There we are. It's going to take a second.
Reads pretty well to me.
So, all right, good. So what this does, it sets up a Gremlin query source. This is a term already familiar from the TinkerPop realm, where we already also have a Gremlin query source. So this is where all the queries would start from. And there's a default object for that, and we would just configure the provider, and in our case, that would be the Gremlin server. This is where we give it the base type for our domain, because it's got to know all the types there are, right? It's got to reason about the types. It's got to reason about your domain types, wherever they are. There's many ways to enhance that, include other assemblies, include all kinds of other types in there, but there's going to be one base type for a vertex, and there's going to be one base type for an edge. And this is the convenience way to configure. This is where we go and tell it to use a slightly modded Gremlin server in a container. The modification, I did a modification of Gremlin server that would behave a bit more like Neptune, because the standard Gremlin server has two differences that make it not suitable to be tested for Neptune development, local Neptune development. One being that its default ID type is a long, and the other being that it already would give you, on a query, would already give you the whole element, including all the properties, which is not what Neptune does. Gremlinq's got a way to get around that, and we're going to use this. And this is why we have the slightly modded container here. So we're going to spin up the modded Gremlin server container and use Newtonsoft.json is a plugin to actually facilitate the deserialization of result sets, because we're going to get back some data and we would have to deserialize it to our domain objects, right? And this is what the Newtonsoft.json support library does. There is a commercial library in the Gremlinq.Extensions that would do this with system text JSON. Today doing these things of dealing with JSON in .NET. I think .NET 6 it started. I don't know. Might be even earlier. But yeah, the standard and open source MIT licensed way to plug in deserialization of result sets is this Newtonsoft.json. So let's put up a breakpoint here, hit F5, and I would assume that in a minute we would see it spinning up the container. These things take so long if you don't have the time. So there's no container already spun up. But the moment you do something with the graph, the moment you do your first query, which is what create air routes small does. So it's got baked in. There's an actual separate library for that. It's got the air routes domain. It would take care of creating those vertices and routes, just a small set, because the large set would take hours, maybe not hours, but it's huge. And thanks to Kelvin Lawrence, they provide a smaller set of sample data. And this is what we're using here. So stepping over this, we should now see, let's see here. Spinning up the Docker container for the modded Gremlin server. And it's going to take a second.
Yeah, it's pretty common. You mentioned why you have this container. Just make it clear to folks. It's pretty common to do that with TinkerGraph. If you're trying to mimic maybe the behavior of another graph, TinkerGraph's extremely good at kind of I don't know, being a bit of a chameleon. You can configure it in ways that make it look and feel like a different graph that may have a lot more back-end infrastructure that you can't use inside of your normal test infrastructure or whatever it may be. So yeah, TinkerGraph's a good thing to use in those cases.
Yeah, definitely, and it's yeah, it's usually pretty fast. It's just my computer that's running slow. All right, so we just hit the breakpoint. This is our first query. And what this would do is to just query all the airports. And I'm going to already hover over these, hoping that a tooltip would appear.
Sometimes the tooltip, I don't know if it's just showing up on your side, but sometimes it won't show up on the stream. I think somebody's had issue with that before.
Oh, right. Okay.
I don't know. Sometimes it just depends on I guess maybe whatever your operating system is, or I know people have had that issue before.
Maybe when we're not running. Okay, let's just step over. And now we got all the airports. We can have a look. Now we got 46 nice airports, all populated in city, code, country, description, elevation, and so on. There's a little shortcoming, which I already fixed, but it's still in here, which makes the longest runway not being in the sample data in the database at all, but that's just some minor detail. So yeah, these are now actual objects in your program, in your C# program, in your .NET program. You got now those 46 airports waiting to, I don't know, to be messed around with, to be dealt with. And let me just stop here and see if we can get it to show. Now we go. Can you see the tooltip
Yes.
now?
Yeah.
All right. So does it show?
Yes.
Don't already think about too much. Think too much about the iVertex Gremlin query part. Just focus on the airport. So every query, every part of a query, every step in a Gremlin query has one element type, and in this case, it's already airport because we told it to be airport, right? We could zoom out. We could just use the untyped version of this and see what it does then. The element type would be object, which is perfectly fine. Gremlinq is able to even deserialize those because it has a notion of something called airport in C# in your classes, and it's got the label. We could actually dive right in and show how it goes. I will just in a minute let the container run on the side to not be started all the time. Let's hope that it. All right, I will just in a minute just run it and leave it there. So remember that the element type on this query was object. So airports should be an array of objects, but is it still going to be airports? Let's see. Let's have a look. And we can see that we got an array of objects, but each of these objects is actually an airport. So Gremlinq is even able, even if it doesn't have the type information on its interfaces, if you're dealing with elements, vertices, edges, it's still able to deduct from the label what this is and what to deserialize to. So just because just because the element type on the query is object doesn't mean you're lost. Doesn't mean the value of Gremlinq is lost. it might just be fine for you after all. However, whenever you want to deal with the airport going further, yeah, if you can tell it what to filter on and what to expect, yeah, you're going to be able to reason about the airport, like in this query down here. So this is one element type. You always have a node type or some other scalar, something like that. We could just walk out one of the route edges. And let's not walk all the way, but let's stop at the edge. So this is what out E does. It would stop at the edge. And we can see that, again, just ignore the in II out edge Gremlin query. Observe that on our interface, in our type system, we now have route and airport. So the interface is aware of where we came from. And it might use this information should we go back, right? So whenever we would now run this query, we would get all the routes there are, right? And should we go back to the vertex we originated from, this would be out V. Gremlinq knows that now we're back to the airport, right? Should we instead decide to go into the adjacent vertex by going in V? We're back to just having an object, right? We don't know better. We could now go airport, put it in those angle brackets. That would apply a filter. So this is just a shorthand for inv of type, which would translate to has label in Gremlin. But this being C# and this link being in the name of Gremlinq, sometimes there's a mix of things that are named just like TinkerPop has it. And there's other things that are more named like the link methods in that .NET developers are familiar with.
I think that's one of the nice things about what Gremlinq is doing, right? It's making Gremlin and just graph querying fit more closely to what maybe the average C# link developer would expect, right? They don't have to find like a new way of programming necessarily. They're just going to be using the stuff and the syntax and the kind of the form that they're used to. I mean, I think that's kind of the pattern. I mean, that's something we always kind of seek to get at in TinkerPop with the language variants that we have. Is how can we make it look familiar? When you're working in Go, it shouldn't look like it was written by a Java developer, right? Like it should look like and feel like a Go expert went ahead and designed that look. And I think that's what's like kind of a really neat thing about what Gremlinq does.
It tries. There's some things I would do differently today. Either put it more closely to TinkerPop or put it more closely to Link, but this is what we have. Then one of the side effects of that is we only have where for everything. Where in TinkerPop we have has and where for different needs. And this always used to confuse me a bit. And in Gremlinq, it's always where. There's no has anything in Gremlinq. So that's some kind of a consolidation here. So should we now decide to go to the adjacent vertex and filter on the airports? We're back to, we are back to an array of airports. and it's again there in your query. So this is one thing. You have your element types. Should they be vertices? Should they be edges? You have them baked in your type on every Gremlinq hop. Then there's scalars. I used to have this count here. So let's say we're going to count the number of airports. Why ever you should do that. Now we got a long. An iGremlin query of long. Again, don't lose yourself already in the different interface now, but the type parameter, the type argument of that, I should say, is long. So now we're dealing with longs, and since we're only going to get one for all the airports there are, we're good with going first async. We only need one. We take the first. There's only going to be one actually, and that's that. So there we got elements, we got scalars. Once you do projections, let's go down here. There's different ways that Gremlinq provides you to project something on the way in a Gremlinq query too. So let's say we're going to all those airports. And now we're going to set up a projection, and we're going to project to a tuple. So a C#, a .NET value tuple. It's got, in our case, it's got 3 properties. I just named item 1, item 2, item 3 because there's no real notion. We could do a cut later on. We could change those names, but essentially in a value tuple in .NET, there's only item 1, 2, 3, 4, 5, and you can project anything to these just by going, take the description of the airport for the first item, take the code of the airport for the second item. These would be expressions just using properties of the airport. But you can have also projections. You could also have traversals, whole traversals. So let's say for the first 2 items, we're going with the description and the code. And for the third item, we want to have the number of outgoing routes. The number of outgoing routes being equal to the number of adjacent other airports going out. So we can do this. We can from any airport, from each of the airports going into this project operator, we can walk the route out edge and count them. And this would give you the third item. So we will end up with a tuple of string long. And we can deal with these perfectly well. They're going to deserialize perfectly well. Gremlinq will handle all of the deserialization for tuples. It's just out of the box. Also, we could project to, and what it gives us, I should say, real quickly, what the project operator gives us is an IMAP Gremlin query. We're going to talk about the IMAP Gremlin query part of that, of tick A being described below as being a tuple string long. So this is nowhere in your domain object. This is nothing Gremlinq knows beforehand about. This is not in the this is not in the domain object, the domain types that Gremlinq knows about upfront, but it's rather dynamic. And presented with it with this query, it'll just take what's there. It'll get the tuple somehow from the database in its result set and just somehow try to deserialize this into whatever is being requested. And I think I should maybe, I haven't tested. I tend to forget some of the things Gremlinq can do. We can do a cast here, and we can give those tuples. We could just rededicate the names of the tuple. Let's say this is a string, but it's called description, or just desk. a string code, and this was long, and we're going to name this outgoing route count. It works, and we can still refer to it by their canonical names of item 1, item 2, and item 3, but it's already giving us a hint that there's better ways to refer to it. So by using the explicitly provided tuple name, we can reason about them by their given names now. And this would go perfectly fine. Under the hood, everything's still an item 1, item 2, item 3, and it's still something that Gremlinq would name those things in its query. But yeah, this would work as well. But instead of
cast is nice. I like that. That's a nice syntax. I think TinkerPop's still missing it. Well, I mean, we have some sort of casting functions now, so it's a little better. But that's really cool. I guess that's like kind of a .NET sort of thing, though. But yeah, I like that.
I would not do this. Instead, I would use a dedicated record for this. So you can have those records, which are just plain objects, just like your airport and your route. But they are not in the graph model of Gremlinq. Gremlinq does not have to know about these, but you can have them. I can show you the declaration of that, where we would have a string property departure code, a string array property destination codes, just the class, nothing fancy, just the properties, and project to this instead of a tuple. The nice side effect being that now we're doubly type safe, because we're going to have, we need to tell Gremlinq the target property to project 2. In this case, this would be a property of departure and destination record. And we got to tell it what it comes from. And this would give us a nice enhancement of type safety, because should I, let's say, wrongly type this departure code as a long, then these things would no longer match, and we're gonna get red squiggles. So we tell it to get the departure code, which is a long, from the code property in the database, but they don't match. So we already have compile time safety here, right? And this is not, maybe not as important in this case, but more important in these cases where you would have okay, I got it. Where you would have a traversal instead of just this projection, where you would still project to the destination codes property of this record, but get it from a traversal on the database. And let's say they don't match. Let's say we don't fold it to an array, but we just end up with a string. We would already get a compile time error here, because destination codes is supposed to be an array of strings, but we're giving it just one string, one code of an airport.
Yeah, so I think the compile time errors are really, I think that's really helpful for the obvious reasons. But knowing before you deploy anything or send it away, and learn that queries are going to the server and getting rejected or whatever it might be. Like I think that's like kind of that's definitely a really powerful sort of feature that you get with building your applications this way.
I do the occasional consulting gig as a side hustle, and I've had customers dealing with this, going with this instead with this tuple projection, not realizing it. They had a type mismatch, and once they introduced a dedicated tuple type or a record for these, it immediately showed up, and they went like, "Oh, this is where it comes from." So yeah, there's some value in there, definitely. All right, that would be. Let me see. We would have dynamics. I would not really. I would not really suggest to use dynamics, but just for completeness sakes, C# dynamics. That's something that dynamics are kind of a fancy way of dealing with objects, but are dynamically bound, just like in JavaScript. So you would have a variable of type dynamic, and you could do all kinds of things, all kind of things with it. Nullability provided. That should work. And it would just resolve these calls dynamically on runtime. We can do this. We can project to dynamics, run wild, do whatever, take whatever we want, and then let's say whenever we have such a record here, use the code property or the description property that we just assigned. But there's nothing really keeping us from, I don't know, introducing typos here, and it would probably still work. So this is for completeness, but don't do it. It's just there to provide something, because I've seen existing code dealing with dynamics, and I think Gremlin.net does its results, that gives you back its results through dynamics, I think. So yeah, this is why it's got into Gremlinq. So that would be the section about the element types. As you can see, all the queries, all parts of a query has an element type. If you even hover over one of those expressions where you would have an airport and project to something from it, you can see your X is also an airport. So you're always dealing with element types on any query, be it an actual element, a graph element, be it a scalar, a tuple, all these things. The other part of Gremlinq's type safety features is in the interface types. And as you already saw, this is not just any type, the most basic being iGremlin query, but this is an iVertex Gremlin query. And it allows us to call all the right methods on something that is a vertex, going out of that, going to an adjacent other vertex, just stepping on an edge, right? Whenever we are here, we are now on an out edge Gremlin query. So not only does Gremlin just now know that we came from an airport, we are on a route, but we also know that the airport is behind us. We just walked that edge, and we are on this out edge with the airport behind us. So it's got all the information baked in here: the out edge, route, and the airport.
Yeah, we've been asked. I mean, I don't know how many times that's come up as something that sort of how Gremlin should perhaps be set up in such a way where there's greater type safety around the steps that can be called for the right sorts of situations, because you could do a lot of things with Gremlin as it is, and write Gremlin that doesn't really mean anything. It means nothing to do I don't know what do a g.v as string out. Like it doesn't have any meaning, and ultimately causes will cause probably some sort of runtime error. So it's kind of nice that you get that right here at the time when you're writing the query, and you know right away that it's not right, if you start mixing and matching those steps in the wrong way.
Yeah, this is when I started this, I wasn't too familiar with Gremlin and its working. So this was a nice way to become familiar with it. And what can I do actually? Where can I go? And what is actually not allowed to do? Yeah. Let's see. Now we got an iVertex Gremlin query. We got 3 kinds of edge queries, edge interfaces. Let's say we would, oopsie, sorry. Let's say we would not walk the out edge of that particular airport, but walk the in edge. Then we would have an in edge Gremlin query. And let me try something. Whenever you would, let's say you would add a route to another airport. Let's say this won't compile, but the types on this should tell us. Yeah. So now we walked on an airport. We added a route to a different airport. So now we know everything. We just after the 2 modulator, we're on the edge. This is not immediately obvious for a Gremlin user, but it's obvious if you use Gremlinq, because it gives you an iEdge Gremlin query, and it's got the route and 2 airports baked in. The route being the element type, because we're now on the route, on the edge. We came from an airport, and this edge is going to an airport. So we got 3 element parameters, element arguments, rather, and 1 iEdge Gremlin query, which is neither an in edge or an out edge. It's just the whole edge with all the type information for everything. And oopsie, I don't do this a lot. So now, should we go further down the road, Gremlinq knows that it's going to be an airport. Should we go back to where we came from, Gremlinq knows that it's an airport, right? So this is a nice addition. If you add, I'm not sure about the multiple use cases of adding routes and just going back, but yeah, there might be some. There might be use cases of adding edges and going right back to where we came from. So you don't lose any type safety here, because Gremlinq's keeping track. We already dealt with a map down here when we projected, and observe that this gives us not only a tuple type of string long. Remember, we projected to a description, a code, and the number of outgoing routes, but also the interface type now is IMAP Gremlin query. And what this would allow us is to, I don't present a lot. What this allows us is to not do the obvious things you can do on any kind of query, but we can now reason about and take the individual tuple elements. So by going select, this is just plain Gremlin, right? This is the same as Gremlin would do it, I assume, like projecting and selecting something from the map you get is also select, right?
Yep.
And we can mimic this here, just going, okay, we just projected and throw two of the items away and just take the first one. Why ever you should do that? But you might use it in a further projection, for example, or going from there, like go from, I don't know, there's nothing to go from. Let's say we're not counting, but we're going to we're projecting to all the airports that we can reach, and we could just now take this. And what would this give us? Let's tell Gremlinq that we're dealing with airports here. So we're going out. We're telling Gremlinq that we're only going to reach airports. And now what this would give us is an iGremlin query of airport. Because we're projecting, we're just taking the item 3 property of the tuple that we just projected to. Now, observe that we're losing one piece of information. We're losing that this was originally a vertex. Now we're dealing with an array of airports. So should we now try to do something with that and unfold it, for example, we would have to give Gremlinq a hint, force Gremlinq to bend your queries in a way it does not know how to do. And I'm going to come back to this later, but just for the time being, there's cases where you would have these things, like you got an array of airports, but Gremlinq doesn't know that it's an array. Gremlinq doesn't know that these were originally vertices, but you can make Gremlinq bend a bit and you can tell Gremlinq how to deal with it. We're going to come back to this later. So that would be selecting individual items of a projection, right? A map in TinkerPop or in Java. I think it's just Java maps that we're projecting to. I'm not too familiar with Java to be honest. And these select methods are only available on the IMAP Gremlin query. So this is another Gremlinq interface type that does something that's not valid on anywhere, everywhere. That's not valid everywhere in any query, but only on select types of queries. Just protecting you from doing things that you're not allowed to, right? So we used fold in here. Let me just go up and go on a green field. So let's say we're going to take all the airports, and now we're folding. Folding means already on the server side going to array for Link developers. So we take all the airports, and instead of having multiple tiny gremlins being on all the airports all way everywhere, we condense them to one single giant gremlin. That's going to represent just one thing that is an array of all the airports. right? That would be, I guess, what TinkerPop calls a barrier step, or reducing barrier step.
Yep.
So in this case, what Gremlinq gives us, the information Gremlinq gives us, I'm not sure if you can see all of this.
Yeah.
So it tells us we have an iArray Gremlin query. It's got the array type, which is array of airports. It's got the element type, which is airport. And we got the original query type, which is iVertex Gremlin query of airport. So now Gremlin needs to know all of these. Should we continue to use this array somehow? So let's say that just in a subsequent step, we are just going to unfold. Just like fold, unfold, shouldn't do anything, right? And Gremlin shouldn't lose any type information here. And in fact, it does not. We're back to an iVertex Gremlin query of airport, because it's got all this type information baked in that it can leverage later on in the query.
Yeah.
Comes at a cost of readability, I should say. Unfortunately, this is rather long. iArray Gremlin query of array of airports, airport, and iVertex Gremlin query of airport, but that's just how it goes. Usually, unless you're really lost, you don't really look at these types. Because once you're familiar with Gremlin as a query language in Gremlinq, you have a model, you have an internal model of these things, and you know where you are, and you know how things are going to come out. But that's how it goes. So there's the iArray Gremlin query, which does just that.
Okay. I just paused for a second just to offer a quick time check. We're about an hour and 15 minutes. So I just want to let you know where we're at, because we're actually, I mean, I'm like happy to just keep kind of going, but just want to let you know where we're sitting right now.
Point made. I could show, let's say, 2 or 3 more of these types, but the story is always the same. You have an interface type that is going to carry some element information, and it enables you to do some things that you're not allowed to do on any other Gremlin interface type. But the story is always the same. So we could skip the rest and just go to, let's say, the many ways to bend your query. Yeah, let's go there, because we're going to take forever otherwise. We saw down here how we can sometimes lose type information, because remember, this is where we projected every single airport to a 3-tuple of description, of a string description, a string for code, and let's say all the airports that it's got an adjacent route to. And what it gives us, remember, it's just a string, a tuple of string airport array. There's now no information. There's type information. There's element information. That's perfectly fine. But there's no information anymore about the original nature, especially that the letter is actually an array of vertices. There's no information here. It's just that. It's just you got the tuple, and this is just, once you select something from it, you only have an iGremlin query of string. So now you actually, if you want to continue dealing with that, you might need some more information. So let's say we're going to deal with the list of airports that we just put up. So for every airport, we are projecting to its description, its code, and all the other airports it can reach, stored in item 3. But now we're back at iGremlin query of airport array, of an array of airports. And this is nothing that we can call unfold on, because Gremlin doesn't know that we're dealing with arrays. So there's no unfold here. So in these cases, and there's times when you run into these, there's only so much a type system can do for you, right? I would like to have it any other way, but what would it take? What would it take? You would have to have a tuple that not only has element types but interface types. It would get real messy. So it's always about keeping a balance in the type system of usability and usefulness. And now we don't have unfold. Maybe we would like to unfold. So what we can do here is we could force this to be an array. And this is the wrong step to begin with, just realizing, because now what Gremlinq tells us, what it thinks it is that it's an array of arrays of arrays, where the element type is an array of airports. So this is not something we would go for. Instead, we would just cast this down to not an array of airports, but just to a single airport. This is where cast comes in. And cast versus of type is, it doesn't do any filtering. Cast is just on the client side. Cast doesn't add anything to the actual Gremlin being sent over to the server. So you don't get any filtering. You're not losing anything. You're just telling Gremlinq, hey, look, this, I know you're thinking you got an element type of airport array, but cast it down to an airport, but force it to be an array. I realize this is, for historical reasons, it maybe should go the other way, where you would force it to be an array. But again, there's a limitation on the type system, because I can't take away the array brackets from something. I can just add array brackets to a type.
You read that you read that tooltip like a pro. I thought you were finished right there, because I was like, look, I was like, oh, how do you fix that typing problem? And you had it right away.
Yeah. And this is, I realized this is not a natural thing to do, because this is really an array of airports. Casting it to a single airport is just plain wrong. But in combination with the force array, we're going to end up with just the right thing here. So now we're back to Gremlinq knowing that this is an array of airports, and we could now call the unfold on it and be good. And this is not perfectly well, but this is a perfectly good query that will succeed on the server side and just visualize perfectly well on the client side. But there's times when you have to bend Gremlinq to your will, because it can lose type information, which is not a shortcoming in Gremlinq, but a shortcoming in type systems, so to speak. I'm happy to learn about these things even more. If there's some clever ways to do away with this pattern, just let me know to the audience. But this is how you would do it. And there's other things you can force your Gremlinq query to be. If you're really sure we are not, let's keep it like this. Let's do the unfold. And now let's say we are sure that we're not dealing with vertices here, but we're dealing with edges. Perfectly fine. Just force Gremlinq to treat it as an edge. It might just run well as well, because there's nothing really that Gremlinq takes from the iEdge Gremlin query part of the interface for deserialization. It will just ignore that part. It will just go forward and deserialize to airport. Not sure, actually, now that I'm thinking about it, but this is something for a different talk. But we could as well just force it to be a value, which is pretty much nothing special, or anything else. So this is what the force methods would do. You can do a cast to anything you like, even if you think you can cast an airport to int just for deserialization or for some other means. I don't know. You can do these things. If you should is a different topic to be discussed. The point being made here is this is often a barrier that developers are being faced with now that they got this object graph mapper and it's being called fancy by its maintainer, obviously. And they're writing queries and they don't really, I mean, they write, let's say they would write this and they now they would like to do something with the array. And now what? They're running into another barrier. So yeah, Gremlinq put down one barrier, and obviously there is complexity in any software puts up another barrier. There is help in these methods. If everything fails and you just wanna bend your query to whatever you feel it should be, you can use the sadmin, which is just blatantly stolen from the TinkerPop world, and change the query type to whatever you feel like. Let's say something like this. This is perfectly fine. You can always just this is not even a cast. This is just look, treat it as something entirely different. So there's ways out of any situation. Of course, you need to do the actual work of thinking about, is this actually right? Will this be something that Gremlinq can deserialize once it comes back from the server, right? But it's there. Let's see, not to take up all the time. We talked about cast lowering. Let's talk for a minute about lowering. Let's go up here. Let's say you now have. I'm just making this up. This might not be something useful. Random route. All right. Of type airport. Let's take a union of two things. One being airports that are reachable, and one being just the route edges. And I'm aware that this doesn't make any sense at all. But now we have a union of what? It's just an iGremlin query of object because there's nothing really that would unify those queries. One being an iVertex Gremlin of airport, and the other being an iEdge Gremlin query of route. There's nothing really that is common to these except for iGremlin query of object. But we know that it's a bit more. We know that these are elements. We might have a common element class, which has the ID. We know that in the TinkerPop sense, these are elements because vertices and edges are elements. So we can do lowering. First, we would go ahead and cast this to, let's say there is a class called element. Yeah, let's just steal it from there. There's no real element class in my project, but there is one in the underlying Gremlin.net. Just ignore that. Just assume that it's there. And do the same for this. And we're still not good. We're still on iGremlin query object because those queries still differ in their actual nature, one being a vertex and one being an edge. So what we can do is call a method called lower that would just lower the nature of the beast, so to say. And one lower than an I-vertex Gremlin query is an I-edge or vertex Gremlin query. That's everything that is either a vertex or an edge. And we could do the same down here. It should give us the same. And now we agree on the types. And now we can agree on the union, the thing that union gives us. So now we have something that is either an edge or a vertex. And we know that it's, in any case, it's an element. We can deserialize it to element. So this is another pattern that sometimes not entirely clear. Developers would go with a union or a coalesce, something that needs a common result type. Coalesce. And not provide agreeing interfaces. And ending up with something they cannot really do something with. So for that matter, for this issue, there is lowering, and you can lower even more, because below vertex or Gremlin vertex or edge, there is probably the type to rule it all. I'm sorry. Oh yeah, there's element. Below that, there's element. What's the difference between an element and something that is either a vertex or an edge? There's a third type of element, which is a vertex property. So by lowering twice, we're now telling Gremlinq, look, this is an element. We don't know what, might even be a vertex property. We can lower even more. This is the end. We can go anywhere from there. But yeah, by lowering, you can bend your, by casting and lowering, you can bend your queries to agree to a common on a common result type, which is particularly not useful but needed for coalesce, union. Help me out, Stephen. Probably some a dozen more of these operators.
Yeah. Oh, that's interesting. I don't remember. I don't remember lower being something we ended up writing about in that blog post. Was it? I don't think that got in there, did it?
No,
okay.
That was it's just,
all right. Well, then you had to be watching this in order to know about lower.
we had to stop writing the article at some point, right?
That's true.
Yeah, I could probably talk all day about these things. So let's just for a minute briefly talk about step labels. There is this as operator in Gremlinq, in Gremlin 2, and I'm never able to memorize, is it the continuation and the label, or is it otherwise? Is it vice versa? So what is it? So what as does, it puts a pebble on wherever we are now. We call that a step label. Yeah, I got it right. So we got a continuation, and this is already strongly typed. It's just what got in is being passed to us in the continuation. It's an I-vertex label of airport, and a step label. The step label as well captures information not only about the element type that it represents, but also about the nature. So should we do something here? I don't know, do something fancy and come back to pick up that step label in a subsequent step, we are back to an I-vertex Gremlin query of airport. And we can just go from there without E and stuff. So this is another concept where type information is baked in, and it's rather long. It's got 2 parameters. There is also a step label derived type that doesn't contain the query type, but only the element type, but you lose the query type subsequently, which is fine because you can force vertex and all these things. But yeah, you can declare these in advance. Let's say declare these in advance and not go with the continuation style, but just pass it to the as operator. Yeah, it's non-null for our purposes. This is something you can do as well. But should you select, as I said before, should you select the pavel, the step label, and pick it up and go from there, you lose the type information. You know that it's an airport, but you don't know that it's a vertex. Easily done. You're back in the game. Not too sure why it gives me this coordinates. What does it expect from me? Never mind, let's go on. That's that for the type system, I would say. Do you want me to go into the domain-specific languages for a bit? There's not a lot to be said about that, other than you have this notion of extension methods in C#. So let's put up a class called extensions, and you would have, let's say, anywhere that you want, anywhere you are on an airport, you want to have a domain concept of the neighboring airports. So your result would be, again, a vertex Gremlin query of airport, but you now introduce this. I should put this static. But now you introduce this concept, which might be a concept of your domain, something that you talk about. I'm not sure. I'm not sure that airport people talk about neighboring airports, but for the sake of this, let's say this is a perfectly fine domain concept. Your neighboring airports, and you want to be able to apply it everywhere you have an airport, and you could bake the walking out just in there. So walk out the route and filter on airport. So this is something, this is very basic. We got extension methods for our domain language that are pretty large, capturing all kinds of concepts to be reused. That's the whole purpose, right? We got this nice side effect being that you can, at some point in your logic, stop reasoning about out routes, out edges, and just talk about your domain concepts through those extension methods, which the set of all the extension methods that do these, I would call a domain-specific language, if you can call it that. This is one way of capturing some notion of schema. It doesn't enforce anything, but given enough hygiene in your code base, you can do a lot with these.
Yeah, you can definitely embed certain elements of schema and constraints into a DSL. Like I've seen that done. I presume it could be done this way. I'm pretty sure this is like a similar way that TinkerPop espouses building DSLs in .NET. But yeah, I've seen there's validations you can do inside of these methods. There's a lot of logic that you can actually pack into these steps, these DSL steps that would enforce schema and do other things for that matter. So it could also be easily abused and put things where it probably shouldn't be in there. So yeah, that's a nice that's a good feature to kind of showcase and with type safety in mind with this, because right, that's like the kind of the thing Gremlinq is bringing.
Right. So now, what would you like to? Should we go into the extensions for a couple of minutes, or should we just?
But I mean, yeah, if you want to just kind of talk about your extensions and what they do, I think that'd be good. Give a quick sort of overview.
All right, thank you. I'll just show one, maybe two of these. These being on.
Yeah, let folks know what they
Usually-
are. I think that's yeah. Let folks know which ones you have, and maybe one will speak to them. But yeah, I think yeah, I think you should list them.
Right. So the extensions you see here are not all available, but you can go to docs.gremlinq.net to see a list of 4 extension packages that are already available for to be bought. One of the packages is the diagnostic package, especially valuable for users of Cosmos DB, of the Gremlin API of Cosmos DB. It still exists. They have been asking a lot for being able to get the request unit, the cost, the charge that Cosmos DB applies to that particular query that they just issued. And so far, there was just this very nasty way of intercepting the execution of a query and do it in a kind of reactive style. And with the diagnostic package, you can actually get a type that has the result in it, but also all the metadata. So you would go, you would not go to array async, but you would go diagnostic to array async, which would give you the result and the request units you just consumed. Very valuable if you want to debug queries that take a little longer or might just be more expensive, see why they're taking so long, why they're being kept. Cosmos DB can even be rate limited at some point. So there's some. I might get back to this, but let me, for developers who have an existing code base of handwritten Gremlin queries, there is this extension called Gremlinq.Extensions.Groovy scripts. And it's got to be configured by configuring the environment of Gremlinq, and just well, how does it go? Add Groovy script query support. That would set up the Groovy script support. I think we talked about this. It should really be Gremlin string. You told me once, but it's out there now. It's not really Groovy. I'm still not entirely sure. I mean, Groovy is everything that maybe not be Gremlin. So yeah, this should be Gremlin script or Gremlin string. But for the sake of this, the package is called Groovy script. Mm-hmm. What it allows us to do is, on the start of any Gremlin query, which is our iGremlin query source, we can execute a Groovy script, and we could even request that it's being strongly typed. So let's say we want to have all the airports, and let's say let's have a look. What this is going to give us back is an async enumerable of airports. So it represents an asynchronously iterable list of airports. So putting an airport as a type parameter is perfectly reasonable and correct. And you could say with script and just go like this. Okay, I see. It takes a builder. Let's say sorry. Let's say we put in a filter on has code, and we interpolate the A in here. Filter. So this is a type-safe way of reusing your existing Gremlin queries without running into the risk of injections. In any query language, you have the risk of injections if you put together a query from possibly user input. And what this does, it gives you a builder and a range of possibly, I don't know, up to 200 and something variables. And you could just use those variables and interpolate them. They're not going to be the actual data you put in, but they're going to be placeholders for bindings. And you could bind to, you can then say bind A to, let's say, LAX. Let's just lose the other ones. Now this is type safe. It's safe to be assembled even with user input. The bindings are explicit. So yeah, this is an option for projects that have already an existing code base on plain Gremlin. There's even another. I think there's even this overload, which just lets you run wide with it. Oopsie. You could just execute that and be happy.
Yeah.
Go to array async and whatnot. There's even an overload where you put in where you could put in, let's say, a binding placeholder, let's say _A, and provide a dictionary that would map the _A to something. There's 3 different overloads for that. But the gist being, you can now issue those queries, still be type safe, and still be reasonably safe from injections.
Yeah, nice. Are there any other interesting extensions?
Let's see. Let's just take one look into for Cosmos DB developers. And then we'll leave it at that. I would just say that there is this aforementioned package to replace Newtonsoft JSON by system text JSON, which is important for some companies or developers that are trying to move away from Newtonsoft. It has served as well. And I should also install for Cosmos DB. I'm just gonna show the API of that. So let's say you have your iGremlin query source. Let's say you go for all the airports, and you want to know from Cosmos DB what it costs, what this query costs you. And there's a bunch of, usually you would say first async, first default async, all these methods to leave your query and do something with it to actually execute. And in this extension package, there's all these methods prefixed with diagnostic. And let's say you go for diagnostic to array async. And what this will give you, just a second. I hope I can F12 into it. Something's really running slow here. We get a diagnostic to array async response. And on this, we got our data. But we also have all the metadata that came back from the Cosmos DB engine. For most developers, the most important being the total request charge. What did it cost? Because they have this notion of request units, and yeah, the more you consume, the more you're likely to be capped and to be rate limited. So then you could just increase your barriers for that, but it'll cost you more and all this. It's in the end, it's a money thing, I would assume. I'm not using Cosmos DB anymore, but yeah, there's other things to be got from this: the total server time, the last status code, which is Cosmos DB internal status code, all these things. The activity ID, which is not OpenTelemetry. There's OpenTelemetry in this package as well. I'm not going to show it now, but there's OpenTelemetry instrumentation in that. So you can have your metrics about the query and logs about the query sent to your OpenTelemetry backend. This is also included in the diagnostic extensions. But yeah, I think for existing Cosmos DB customers, this is something that has been asked from me for a long time, and it's there. You can buy it, take it, be happy.
Okay. Very good.
Yeah, I should stop plugging the extensions now. Go to .Gremlinq.net. There's 4 extension packages. And if you feel that your company needs somewhat different, you need a bundled offer, an offer per se, let me know. There's an email address.
All right. Very good. I don't know. Is there anything else you wanted to bring up? If not, we could maybe just have a couple questions, I guess.
Just run wild.
I guess maybe one question that is perhaps worth asking is about just performance trade-offs with using Gremlinq. We didn't really touch on any of that here. What have you seen in that area, and what can you share about it?
Come again, please. I didn't.
Oh, just what can you share about the performance trade-offs of using Gremlinq?
Of course, there is some penalty. I went great lengths to minimize the allocation impact, the hot paths. So there's optimizations throughout. There's caching involved. There is all kinds of stuff. I'm really sensitive to allocations and how to avoid them. There are allocations. Every time you use an operator on something, it's going to give you, as we have seen, an interface which is actually an object. It'll be implemented by an object. Sometimes when you do some casting and it can already be represented as that object, you can get away with no allocation. But yeah, every hop in the query is going to be one allocation, which is usually given. I mean, it's a matter of taste in the end of what you're trying to optimize for. If you're trying to optimize productivity, type safety, it's all values for to be regarded as for themselves, and they are highly everything you catch on on client side, on compile time, is worth actual money. So you got to be aware there's allocations involved in constructing the query. There's allocations involved in the expressions that you put in, like the x code equals LAX and so on. There's an allocation for that. There's allocations, obviously, when you deserialize your airports. If you're just interested in the code, just ask for the codes instead of deserializing all the airport. You're going to get less data back, and there's less work to be done. There's allocations being done in constructing the actual bytecode from a query. So you got the Gremlinq query. You have to construct bytecode to be sent away to the server. That's going to be allocations. You have to serialize it to the wire. This is already highly optimized, but there's always more. But you have these things as well in any other framework. Like if you would use Gremlin.net, it doesn't give you a new object back for every operator, I guess, because it doesn't have that notion of immutability baked in. But it still has to construct bytecode to send over, or even a graph binary, or in a subsequent version something different. So there's always overhead whenever you do these things. There is overhead. Measure early, and do the trade-off. Is it worth it for you? We observe these queries to be fast, and this is not advertisement talk. Like we have put up a great GraphQL API on our database that would form one single Gremlinq query for any GraphQL query, no matter how complex. And we got some complex things. We got queries in that would serialize to 20 kilobytes of bytecode data, and they are fast.
20 kilobytes, really? Wow.
Yeah.
That's a big hunk of Gremlin, if I'm hearing that right.
Yeah, because the queries on our GraphQL API are already complex, but it's fast. It's reasonably fast, but you have to measure for yourself in the end. It's a trade-off.
Yes, that's true. That's true. Okay, well, good. I think I think that's I think this was interesting. I definitely learned a few more things about Gremlinq today that I didn't even learn from writing an entire blog post about it. So that was good. Appreciate the sort of in-depth drop into to some of these details here. Anything else you want to share before we kind of call it for a day?
Thank you for the opportunity. Thank you for the interest. Thank you for hanging in for 2 hours. I know we didn't have a hard limit, but I thought, okay, hopefully I won't be done after 10 minutes. It didn't go that way.
Okay, well, sounds good. Thank you so much. We'll let's we'll see you around on Discord and elsewhere. And thank you everybody for kind of listening to this. And hope you all learned something. See you on the next one. Take care, everybody.
Take care.